Let's do some exploration with problem solving and estimation. Now, I think that this is a skill that we lack in the world right now. So if you think about any problem solving that you need to do anywhere in the world, it doesn't matter. If you can think about these 4 steps, it makes it a little bit easier. So what is the problem we are trying to solve? Let's understand what we're trying to solve. Then we can make a plan. This is my problem. This is my plan to fix it. Do that. Carry out the plan, and then look back and reflect. Did it work? If it did not, do I need to change something and try again? Evaluate your decision. This works. It's not just in mathematics. It's everywhere. All right, let's do this. So first we're going to estimate how many pennies would it take to cover one of your walls. With this, we're talking about area, right? I'm going to take a wall and I'm going to cover it with pennies. Now, this is an estimation. I don't believe it would be a good idea for anybody to get a bunch of pennies and then glue them to your wall. Horrible idea. Okay, so let's think about what we know. We know that the diameter of a penny, I Googled this. Diameter of a penny is 3/4 of an inch. That means the radius is half of that, which makes it 3/8 of an inch. So if I want to find the area of the penny, I take pi times radius squared. So pi times 3/8 squared, which is roughly 0.442 square inches. That's the penny. So that's the area of 1 penny. Okay, I love this for us. This is amazing. Now, a wall. Pick a wall. I don't know the size of my walls. I estimated, and I said, I think my wall is 12 foot by 14 feet. This is an estimate of the wall I chose. Estimate any wall you want. What is the area of this wall? Well, 12 times 14 is 168 feet squared. But you'll notice inches to feet, that doesn't work so well. So I'm going to take 168 feet squared, and I'm going to change that because 1 foot is 12 inches. So I can do that twice, and now I have inches. So this is the same as 24,192 square inches. So if I take my entire wall, right, this is my wall, and I'm going to divide it by 1 penny. How many pennies will it take? Roughly, rounded to the nearest penny, 54,733, oh, we're going to need that to be plural, pennies. Y'all, that's a lot of pennies, like a lot of pennies. So that would be my estimation to cover a wall. But if we're talking about area, find the total area we need to cover, find the area of an item we want, and divide, and we can go from there, right? So that's kind of a fun thing to do. Let's do another one. How many books would it take to fill your room? So now we're talking about volume because we're filling it up. So now we got to think about a book dimensions. What are the sizes of, and here now you're like, well, what kind of book am I reading? Am I reading a soft cover romance novel? Am I reading a hardback, newly released mystery thriller? Am I reading an Algebra 2 textbook? Right? Those are all different sizes of books. So I estimated my book to be 8 inches by 4 inches by 1 inch. That's kind of a book that I have on my shelf is roughly that size. So with that being said, the volume of this book, length times width times height, is roughly 32 inches cubed. This is also an estimation. I didn't measure any of this. I looked at a book and said, that's pretty close. Now, what about my room dimensions? I'm going to guess that my room is 12 feet by 14 feet by 16 feet. I have no idea if this is true. I just looked around and said, maybe, maybe not. Heck, I don't know. But when I find the volume of that, length times width times height, I get 2688 cubic feet. Now, similar to our last problem, if I need cubic feet to become cubic inches, I do the same thing of 12 inches over 1 foot, and I've got to do that 3 times. So that makes my feet cancel out. I'm now in inches. So this is equal to 4,644,864 cubic inches. So that means if I have a cube that is 1 inch on each side, that is how many of them I would need to fill up this room. And again, this is an estimation. So now, if I take the room and divide it by the books, that'll tell me how many books I need. So 4,644,864 divided by 32 tells me I need 145,152 books to fill up my room. Y'all, that sounds so good to me because I love books. So I would not mind having a whole room full of books and I could just read them one at a time. That makes like my life real happy. Let's do one more just for fun. How many pieces of fruit would it take to fill a bathtub? Okay, so now we're also talking about volume. So I Googled, what are the sizes of a bathtub? Because we need to find, again, the volume. So I found that a bathtub is generally 60 inches by 30 inches by 16 inches. Okay, so that makes the volume of a bathtub at 28,800 inches cubed. And then we think about fruit. Y'all, there's so many different pieces of fruit, and the answer changes. I picked an orange. I think I was just craving an orange. But you could pick a banana. You could pick that would be kind of like a cylinder. You could pick a pineapple, which would be like a cylinder. Apples, blueberry. Oh man, how many blueberries would it take? A lot. But I picked an orange, and I found that an average orange, turned off my pen, is 3 inches in diameter. That makes it 1.5 inches as a radius. So to find the volume of a sphere, 4/3 pi r cubed. So that's 4/3 times pi times 1.5 raised to the third power, which is approximately 14.14 inches cubed. Seems real big. It is what it is. Okay, so that's what we find to be the volume. And then I say, okay, if I need 28,800 inches cubed over 1414, that gives me 2,037 oranges. I need to check this math again. Hold on a second. Yeah, I checked it. That's what I got. So I guess it is what it is. Yeah, there we go. 2,037 oranges to fill up that bathtub. That seems right. That's a lot of oranges. And that's estimating with problem solving. You can always have a lot of fun with math and fruit.